In Chapter 8.2, we're going to solve a system of equations through addition. We're not going to be graphing anymore, not until we get to Chapter 10 at least. And when we solve a system of equations through addition, all we're going to do is add these two equations. So in this particular case, what we're going to do is take x minus y equals 8 and x plus y equals 2. Add those together. X plus x gives me 2x. But a negative y and a positive y gives me 0, and that equals 10. So what I have is 2x equals 10, and then 2x over 2 equals 10 over 2, and x equals 5. Now what I do is I can take either one of those equations. So let's take the first one. X minus y equals 8. I substitute my value for x in there, and I have 5 minus y equals 8. Subtracting 5 from both sides, I now get negative y equals 3. But since I want it to be a positive y, I just divide both sides by negative 1, and I get y equals negative 3. Now, what our pair of numbers turns out to be then is x is 5, y is negative 3. And just to verify that, let's take a look at our second equation. X plus y equals 2. If we had x plus a negative 3 equals 2, we would have 5 minus 3 equals 2, and 2 equals 2. So that works. And if you wanted, you can verify with the first equation, but I can guarantee you that's what's going to work. So there we have it. That's the simplest example, but now let's take a look at number 8. In number 8, we have identical x terms, but they're both positive. What I want to do is make one of them negative. So what I'm going to do with this second one is I'm going to multiply that whole thing through by a negative 1. When I get that, what I'll have is negative 5x plus 2y equals negative 19. Now I bring my first formula down, 5x plus 4y equals 7. Now I've got these two in the format that I want, where I have a positive and a negative same value. These x's now will cancel out, and I will get 6y equals negative 12. Dividing 6y by 6 and negative 12 by 6, I'll get y equals negative 2. Now, going back to either formula, and so I kind of prefer the one at the top. 5x plus 4y equals 7. So I have 5x plus 4 times negative 2 equals 7. I have 5x minus 8 equals 7. Add 8 to both sides, and what I get is 5x equals 15. And now if I divide both sides by 5, I get x equals 3. Now in this particular case, when we solve this, we solve for y first. But when we put our coordinates down, we have to remember that the format is xy. So our solution is 3 comma negative 2. Just remember when you're doing that, that's the way it's written. So now we've done number 2 and we've done number 8. What I'm going to do is I'm going to erase all of the material we have so far. So I want to have kind of a clean board for number 20. I've written number 20 clear over on the right-hand side, but I'm going to rewrite it in the middle because there's going to be a lot of steps with number 20. If you'll notice in number 20, what we've got is negative 4x plus 5y equals negative 6. And then we've got 5x minus 2y equals 16. We don't have anything matching there. It's a negative 4x, positive 5x. We've got a positive 5y and a negative 2y. So what we're going to do is we're going to have to multiply through by some factor both equations. I'm looking at that and I'm saying to myself, you know, I'm going to focus on the y's this time. If I multiply that first equation through by 2 times negative 4x plus 5y equals negative 6. Okay? And then I multiply that second equation through by 5x minus 2y equals 16. Okay? We're just doing that off to the side. What we get in our first equation now is a negative 8x plus 10y equals negative 12. And when we multiply through in our second equation, we'll get 25x minus 10y equals 80. Some big numbers here. But now what we've got is we've got these two values, the plus 10y and the minus 10y. And we know when we add those together, they're going to cancel out. What I have now is negative 8x and positive 25x. I'll end up with 17x. And now when I have a negative 12 but a positive 80, I'll end up with a 68. Now I take 17x over 17 equals 68 over 17. And you know what? If I divide 68 by 17, I think it comes out to 4. Isn't that nice and convenient? Whole number sure is nice. If it was a fraction, it'd be a bear to work with. Now I can substitute back into one of my original formulas, and I'll take that first formula again, even though it's got that negative there, plus 5y equals negative 6. So I have now, I'll substitute in for the x. So I have negative 4 times my x was 4 plus 5y equals negative 6. This is negative 16 plus 5y equals negative 6. Adding 16 to both sides, what I get is 5y equals 10. 5y over 5 equaling 10 over 5, I get y equals 2. So the pair of numbers that works for these systems of equations or linear equations is the pair x is 4 and y is 2. And if you want, you can verify that by checking it out. But we're going to move on to some of the story problems, because what I want to do is talk about not solving them so much. I'll let you do that. How do you set them up when you have both x and y variables? Actually, you could do these without having both x and y variables. We've done problems like this in the past. But now, since we can use both x and y, and we have ways of solving this using the addition property, let's take a look at problem number 40. What it says is the sum of 5 times one number and a second number. So I'm going to let x equal one number, and then I'll let y equal the second number. And what it says in that first sentence is the sum of 5 times one number, 5x, and a second number plus y equals 10. The difference between the two numbers is 8. All right? So my second formula then will be the difference is x minus y equals 8. And now we've got a simple problem that we can solve. My expectation is that you will solve these problems. Not just set them up, but you need to solve them. Let's drop down now and take a look at number 44. In number 44, it says Xavier bought 5 Red Delicious apples and 4 Granny Smith apples at a cost of $4.81. Dean bought one of each kind at a cost of $1.08. Find the cost of each kind of apple. So let's let X equal the Red Delicious. And therefore we'll let Y equal the Granny Smith. Looking at our first statement, when Xavier went out, he bought 5 of the Red Delicious, or 5X, and he bought 4 of the Granny Smith, which is 4Y. And how much did he pay for them? $4.81. Dean went out and he only bought 1 of each. So he bought 1X, 1 Red Delicious, plus 1Y, 1 Granny Smith, and he only paid $1.08. There you have your 2 formulas. Now you'll notice what we're going to have to do is multiply that second formula by -1. Oh, actually, if we're going to use the addition problem, we're going to have to multiply it through by either -5 or -4 in order to solve that, because we have nothing but positives there and we have to get something as being negative. If it were me, I'd multiply it through by -4, because what that would give me is X equals and then whatever that total happened to be at the other end. But go ahead and solve that one, number 44. Well, you don't need to solve it. In fact, I'll give you the answers. The Red Delicious was 49 and the Granny Smith was 59 cents if you want to solve those. And I want to move on down, and we're going to take a look at a couple more problems before we call it a day. We're going to take a look at problem number 52. In 52, it says an 8-foot long 2x4 is cut into 2 pieces. I love to draw pictures. So I got this 2x4, okay? And it's 8 feet long. But I cut it into 2 pieces. So what I did was I made a cut right there. Oops, I made that cut way too big. Made a cut right here. And so now I have 2 pieces, okay? And what I can say is we'll let X equal the longer piece, and therefore we'll let Y equal the shorter piece. And so I can label this is X, this is Y. And if I take X plus Y, that will equal 8 feet. The next thing it says is one piece is 2 feet longer than the other piece. Well, we know that X is the longer piece. So if we take the longer piece and we subtract from that the shorter piece, we get 2 feet. Now this one will be real easy to solve, and the answers for that are 3 feet and 5 feet. The last one I want to take a look at is number 60. With number 60, we're talking about solutions and stuff, and we're talking about percentages. And you have a number of percentage problems there. So let's take a look at this. It says a pharmacist wishes to prepare 150 milliliters of a 20% alcohol solution. She has a 30% solution and a 15% solution in her stock. How much of each should she use in forming the desired mixture? So she's forming this solution. We're going to put that in a beaker here. Yes, indeed. Okay. And in that beaker, she has 150 milliliters. All right. So she's got 2 different solutions. She's got, let's say, we'll let X equals solution number 1, and we're going to use y equals solution number 2. And what we're talking about is how many milliliters of each. So if we take the milliliters of one plus the milliliters of other, x plus y, we end up with 150. That one's pretty simple. But what we're doing is we're going to mix the solutions. So it says here she has a 30% solution and a 15% solution. We're going to go ahead and say we're going to take 30% of x plus 15% of y, and that's going to be a total solution, a 20% solution of the total, which is 150. But we just have a bunch of percentages listed there. What we remember from percents, that's back in basic 1 or maybe in high school when you talked about it, is 30% converted to a decimal is 0.30x plus 0.15y equals 0.20 times 150. Now, if we take that out, we're going to go 0.30x plus 0.15y now is equal to 30. And in our other formula, which is, we still have it, it's up here. If we go ahead and take x plus y equals 150, now what we have to do is we have to multiply through by something if we're going to solve this through the addition property. We can multiply everything through by 0.30, or we can multiply it through by 0.15. Either way, it works well, but we also need to remember that since we have nothing but positive signs there, we probably want to multiply this thing, and I'm going to say that when you do the multiplication, multiply it through by a negative 0.30, because what you end up with then is a negative 0.30x plus, I'm sorry, not plus, but now it's going to become minus 0.30y equals, and if you take 150 times 0.30, what you're going to get is 45, and that's going to be a negative 45. Now you're ready to combine that one with the equation that we had up here. And that's this equation right here. And you can go ahead and solve. 0.3, oops, sorry about that. 0.30x plus 0.15y equals 30. And you'll get your answers. All right, so now you know how to set up some of the story problems. If you have any difficulty with them, of course, I'll be available in class.